Solar energy project. Understanding solar energy. Solar energy is derived from the sun's radiation, which can be converted into thermal or electrical energy using various technologies. The two most common methods for converting solar energy into usable power are photovoltaic (PV) systems. These use solar panels made of semiconductor materials, typically silicon, to directly convert sunlight into electricity. Concentrated solar power (CSP) systems. These focus sunlight onto a small area using mirrors or lenses, creating heat that is then used to drive a steam turbine to generate electricity. Both methods can be used in solar energy projects, depending on the scale, location, and energy needs of the target area. Components of a solar energy project. A solar energy project involves multiple components working in sync to capture, convert, store, and distribute solar power. These components include solar panels, the core of a PV system, made of multiple photovoltaic cells that convert sunlight into direct current, DC, electricity. Inverters, devices that convert the DC electricity generated by the panels into alternating current, AC, electricity, which is compatible with the electrical grid or household appliances. Batteries, used to store excess energy for use when sunlight is not available, such as during cloudy days or nighttime. Mounting structures. Solar panels are installed on either ground-mounted racks or rooftops to ensure optimal exposure to sunlight. Monitoring systems. Tools to track the performance of the solar system, ensuring it operates efficiently. Grid connection. In grid-tied systems, solar energy is fed directly into the local power grid, reducing the demand for fossil fuels. Planning a solar energy project. Site assessment. The success of a solar energy project depends heavily on the location. Key factors include solar irradiance, the amount of solar energy received per square meter at the site. Locations with higher radiance levels are ideal for solar energy projects. Geography and climate. Sunny regions with minimal cloud cover are more suitable, though solar energy systems can work in a variety of climates. Land availability. For large-scale projects like solar farms, sufficient land is required to house arrays of panels without obstructions. Feasibility study. A feasibility study is essential to determine whether a solar project is viable from technical, financial, and regulatory perspectives. It involves cost analysis, estimating the capital investment for solar panels, installation, infrastructure, and maintenance. Energy yield predictions. Forecasting the amount of electricity the project will generate based on site conditions. Grid accessibility. Ensuring that the energy produced can be efficiently fed into the power grid or stored for future use. Environmental impact assessment. Evaluating any potential negative impacts on the local environment, such as habitat disruption. Project design and engineering. Once the site and feasibility study are completed, the design phase begins. This includes system sizing, determining the appropriate number of solar panels to meet energy requirements. Array layout, optimizing the placement of panels to maximize sunlight exposure throughout the day. Wiring and electrical design, planning the electrical configuration to ensure safe and efficient energy transmission. Implementation of solar energy projects. Permitting and approvals. Before construction can begin, various permits and regulatory approvals must be obtained. These can include environmental permits, ensuring the project complies with environmental regulations. Building permits. For rooftop installations, structural assessments may be required to confirm that the building can support the weight of the panels. Grid connection agreements. If the project is grid-tied, an agreement with the local utility company will be necessary to allow energy to flow between the system and the grid. Procurement and installation. Once the necessary approvals are in place, the procurement of materials begins. Solar panels, inverters, mounting hardware, and other components are sourced from manufacturers. The installation process involves ground preparation. For ground-mounted systems, the land may need to be leveled or cleared of vegetation. Panel installation. Solar panels are installed on racks or rooftops in the optimal configuration. Electrical setup. Inverters, wiring, and monitoring equipment are connected to ensure the proper flow of electricity. Commissioning. After installation, the system must be tested and commissioned to ensure it is operating as designed. This includes performance testing, grid synchronization, and safety checks. Challenges in solar energy projects. While solar energy projects offer tremendous potential, they also face several challenges. Intermittency. Solar power is dependent on sunlight, which is not available at night or during cloudy weather. This requires effective energy storage solutions or backup systems. Initial costs. Although solar energy can save money in the long term, the upfront capital costs for installation and infrastructure can be high. Land use. Large-scale solar farms require significant land area, which can be a challenge in densely populated regions or areas with competing land uses. Grid integration. In some regions, the local electrical grid may not be capable of handling large amounts of intermittent renewable energy, requiring grid upgrades. Benefits of solar energy projects. Despite the challenges, solar energy projects offer numerous benefits. Environmental impact. Solar energy reduces reliance on fossil fuels, significantly lowering greenhouse gas emissions and helping to combat climate change. Energy independence. Solar projects reduce dependence on imported energy, enhancing energy security. Cost savings. Once installed, solar systems provide free energy from the sun, reducing electricity bills for households and businesses. Job creation. The solar industry creates jobs in manufacturing, installation, and maintenance. Future of solar energy projects. The future of solar energy is bright, with ongoing advancements in technology, efficiency, and cost reductions. Emerging trends include floating solar farms. These are installed on bodies of water, allowing the dual use of land and water resources. Solar storage integration. Improved battery technologies, such as lithium-ion and flow batteries, are enabling more efficient energy storage, addressing the intermittency issue. Solar-powered transportation. Solar energy is being integrated into electric vehicles, charging stations, and even highways. Community solar. This allows multiple households or businesses to share a single solar energy system, making solar power more accessible to those who cannot install panels on their own property. Solar energy projects are a crucial component of the global transition toward clean and renewable energy. As technology continues to improve, the cost of solar power decreases, making it more accessible and viable for widespread adoption. By addressing challenges like intermittency and grid integration, solar energy has the potential to provide a sustainable and environmentally friendly solution to the world's